Assalamualaikum and a very good day. My name is Zukri Balatif. So today I would like to present my final project. So my title for this project is Development of Software for DUVAL, Triangle and Pentagon Interpretation on Transformer or Dissolved Gas Analysis. So my supervisor is Dr. Muhammad Fairuz Muhammad Yusof. So to both of my panel, which is Prof. Madya Dr. Muhammad Random bin Bahrom and Encik Suhaimi bin Saiman. Next, I will continue on the project background. During energy transfer in the power transmission, power transformer require a high degree of stability and reliability. As any fault that happen within the power transformer will bring huge impact on the power system. So to make sure that the power transformer at its best condition, we need to diagnose it using diagnostic tool. One of the diagnostic tool is dissolved gas analysis, which is DGA. So after the DGA is obtained, DGA comes in concentration of gas. So after DGA is obtained, we need to interpret the DGA. Of course, there are many ways to interpret this DGA. So I will be focused on two methods, which is DUVAL triangle and DUVAL pentagon. Next, I will continue on to the problem statement. The problem statement for my project is manual DUVAL triangle and DUVAL pentagon interpretation may consume more time than it should be in today's time. Next, DUVAL triangle can analyze 3 types of gases, while DUVAL pentagon can analyze 5 gases from the DGA. The last problem statement is from the past research that the software that implement DUVAL pentagon interpretation on DGA has not been developed yet. However, the software for DT has been developed in the past. There are 3 objectives for my project. The first objective is to apply DT and DP for interpretation of DGA sample from TMB. The second objective is to compare and analyze the result from DT with the result from DP. The last objective is to develop a graphical user interface GUI software for DT and DP interpretation. Next, I will continue on the scope of study. The first scope is DGA or result from TMB transmission will be used. The minimum of 3 results from TMB transmission was analyzed. The analysis was conducted using DT and DP. Lastly, the graphical user interface GUI function in the MATLAB software was used to develop the software for DT and DP interpretation. Next, for DUVAL triangle interpretation method. So Michael DUVAL introduced 5 types of triangle to interpret the DGA result according to the term of each triangle. However, for my study, the DUVAL triangle 3 for transformer filled with non-mineral oil will be excluded in the paper because TMB emission use mineral oil filled transformer only in their power system. So here we can see that the first DUVAL triangle DT1 is proposed by Michael DUVAL. So we can see that the triangle, the region of the fault in the triangle with the table of the identification for the fault in DT2. Next, here we can see the DUVAL triangle 2. Okay, the DUVAL triangle 2 is used for load type changer transformer, which in short term is LTCS. DUVAL triangle 2 is used for conventional compartment type LTCS, which involve mostly upbreaking in the oil. So we can see that the DT2 is different from DT1. The region of the fault is different. So we can see that in the table is the integration of the fault zone in the DT2. Now we go to the DT4. Okay, DT4 we utilize the gas of H2, CH4 and CH2H6. So when to use this DT4? DT4 is used when DT1 indicate PD, T1 and T2. Then we can use DT4. If not, just use DT1. Okay, so we can see that same as previous, we can see that the table for the identification of fault zone for the triangle. So here is the last triangle, which is DUVAL triangle 5 DT5, that will be used in this paper for my project. Okay, so DT5 is utilized CH2H4, CH4 and C2H6. So the DT5 is used to define the mixture of fault. Okay, DT5 only can be used when DT1 indicate the fault of D1 and D2. So we can see that as the same as before, we can see that identification fault zone for DUVAL triangle 5. Okay, now we carry on to DUVAL pentagon. So DUVAL pentagon, there are two, which is DUVAL pentagon 1 and DUVAL pentagon 2. The concept of DUVAL pentagon is still the same with DUVAL triangle. However, in DUVAL pentagon, the gas will be used is 5 type of gas, which you can see in this figure, 5 type of gas. So the table will show the identification fault zone of the DUVAL pentagon 1. Next is DUVAL pentagon 2 DP2. We can see that the DP2 is quite familiar with DP1. However, there is some difference in the region. So we can see that here is differ than DP1. I will continue on the methodology. So in the flowchart I provided, you can see that the process of completing this project from start to the end. The equation that will be used in this project is the relative percentage of gases. So in DT1 and DT2 we'll be using this equation, which is the equation for ethylene, methane and acetylene. The next equation that will be used is the equation of gas percentage for DT4. We can see that the formula is quietly the same. However, we need to change the gases. So we can see that the hydrogen is changed before. Next is the equation for DT5, which is the same. However, the type of gas is changed to according to the gas used in DT5. Okay, you can see here is the equation of gas percentage for DP1 and DP2. You can see that there is type 5 equation. So we can see that the first equation for ethylene, methane, acetylene, hydrogen and ethane. The next equation that will be used for DUVAL pentagon, which is the equation for centroid. We can see that this in equation 3.15, you can see that the centroid of x coordinate. If in equation 3.16, the centroid coordinate for y. For equation 3.17, which is the equation of area of the irregular polygon after the 5 gases has been plotted on each axis. Next, I will carry on to the software implementation. So you can see in this figure I've provided a coding to plot the red dot in DT software. This is just a partial coding. However, the full coding is too long, so I cannot provide it. Next is the coding for plotting the red dot in DP software. So you can see that this is the equation for the area that I explained before. This is for the centroid of the x coordinate, and here is for the centroid of the y coordinate. Then it will plot the cx and cy in the axis. Now I will carry on to the preliminary result. This result was obtained by using DUVAL triangle in Excel. So for case 1, you can see that DT1 indicate the fault is PD, which is corona partial discharge. For DUVAL triangle 4, it indicate the fault is same PD. For triangle 5, which is also the same PD. Then the case 1 is continue to be interpreted using DUVAL pentagon. So here we can see that the DUVAL pentagon 1 indicate the fault PD, which is the same with DUVAL pentagon 2 PD. The fault is partial corona partial discharge. Okay, this is the result obtained for case 2. So for case 2, DUVAL triangle 1 indicate the fault is PD, partial corona discharge. For DUVAL triangle 4, the fault indicated by DT4 is O, which is overheating. You can see that the plot is at here. Next, using triangle 5, DT5, we can see that the fault in DT5 is also O, which is overheating. Okay. Now here we can see that the case 2 is interpreted using DUVAL pentagon 1 and 2. DUVAL pentagon 1 indicate the fault is S, which is stray gassing. For DUVAL pentagon 2, it also indicate the fault is S. Okay. For the last case, case 3, DUVAL triangle 1 indicate the fault is D1. So as we know, if the DUVAL triangle 1 indicate D1, PD and D2, so there is no need to proceed the interpretation using DT4 and 5. So we'll be going to the DUVAL pentagon and DUVAL pentagon 1 and DUVAL pentagon 2. Here we can see that the fault identified using DUVAL pentagon, which is D1. DUVAL pentagon 2 also D1. Now we'll be discussing on the GUI of the software developed. So we can see here I provided the screenshot of the GUI for the DUVAL triangle software. So we can see that here is the where is the user need to insert the gas concentration. Here is some note that user may need to read before using this software. This is the fault zone identification. So we can see PD, corona partial discharge, D1. So each short term has its definition. This is the GUI for the DUVAL pentagon software. So we can see that the concept is still the same. The user need to input the gases concentration, the fault zone, and the graphical of the DUVAL pentagon 1 and 2. Okay, now we continue on the demonstration of the GUI software. So this is the interface for the GUI software that I developed. So we will try it for case 1. So we input the data for case 1. Here is the gas, so we feed in the blank. So hydrogen is 390, C2H4 CH4 13, acetylene 0, C2H4 0, 2. So once we get the concentration of gas inserted in this GUI, so we can click the button start. So after we click the button start, so we can see that in each triangle we can see that the plot of the fault. So in this case, triangle 1 is PD, triangle 4 is S, and triangle 5 is PD. So for 3 cases, we'll be repeating this step for DUVAL, triangle, GUI software. Next, I will be demonstrating the GUI software for DUVAL Pentagon. So the step is the same as the GUI for DUVAL triangle. We just input the 5 cases. However, for this GUI, the value of 0 need to be replaced by 1. After filling the blank, we need to we can push the button. So after the button is pushed, we can see that the Pentagon 1 and Pentagon 2 identified a fault, which is PD, identified by the red dot. So it is the same for Pentagon 2. So here is the result using GUI software that I demonstrated before. So this is the result from DUVAL triangle GUI software for case 1, as you can see in the figure 3 figure in this video. So here is the result for case 1 by using GUI software. So here is the result for DUVAL triangle, as you can see in the 3 figure in this video. So here is the result after using the GUI software for case 1, as I showed before. So we can see that the triangle 1, 4 and 5 shows the fault for case 1. Case 1 continue. So here so we continue on the GUI software for Pentagon. So here is for case 1, Pentagon 1 and 2 shows the fault indicated by the GUI software. Okay, the case 2 is like for case 2, the fault identified by GUI software DUVAL Pentagon, DUVAL triangle, sorry, is shown in this figure above, 3 figure above. So we continue on to the GUI software for DUVAL Pentagon. Here for case 2, we can see that the fault indicated by these 2 pentagon, which is as indicated by the arrow. Here is the fault identified by GUI software for DT for case 3, and we can see by the indicating arrow. So for GUI software for DUVAL Pentagon is shown right here also. However, the software does not plot anything in the GUI. Here shows the table for identified by using Excel. Here is the fault identified by using GUI software for DUVAL triangle and DUVAL Pentagon. So we can see that there are 2 main differences between these 2 results, which is in case 1, which is in DUVAL triangle 4. As you can see, in the Excel, it produces a fault of PD. However, in UI software, DUVAL triangle 4 identified the fault as S. This error caused by the negative value of X coordinate by the center of UI software. However, both coordinate of centroid have the same value of Y coordinate. So the second differences we can see is in dual pentagon 1 and 2 for case 3. As we can see here, in case 3, the Excel for Excel, using Excel, it identified the for as D1 and D1 for dual triangle 1 and D1 for dual pentagon 2. However, in UI software for dual pentagon 1 does not plot anything on the graph. Same also for dual pentagon 2. It also do not plot any dot on the graph. As for conclusion, the UI software for DT and DP was successfully developed using App Designer MATLAB. However, there are a few issues of accuracy where the certain case of fault identified by DT and DP software were not the same with the fault identified using Excel. Those issue that occur will illustrate in the result and discussion. So for future work, the algorithm of the UI software needed to be revised again to get rid of the inaccuracy issue, and there will be an addition of conditional algorithm to the current algorithm to increase the accuracy of the UI software. I think that's all from me. Thank you. Here is where both of the result from PSM1, which is using Excel, and PSM2 using UI software. So we can see that both results are represented in respective table here and here. The differences we can see in between these two results is in DT4 for case 1, which is by using Excel we obtain the fault is PD. However, using UI software we get the fault for the rectangle 4 is S. This error caused by the negative value of S coordinate for the intersection for the 3 concentration of gas. However, both coordinate of the centroid have the same value of coordinate, which means in the future there will be more conditional statement in the coding. Okay, for the second differences is in DP1 and DP2 for case 3. In Excel we obtain that the DP1 for case 3 identified D1 as the fault, and dual pentagon 2 is D1 for the fault. However, in GUI software, the GUI software cannot plot any dot on the graph for dual pentagon 1 and dual pentagon 2. So in conclusion, the GUI software for dual pentagon and dual triangle was successfully developed using App Designer MATLAB. However, there are issues of accuracy where in certain case, as I stated before, the fault identified by the DT and DP software were not the same with the fault identified using Excel. Those issues that occur were illustrated in the result and discussion previous. So for future work, the algorithm of the GUI software needed to be revised to get rid of the inaccuracy issue. There will be an additional of conditional algorithm, as I stated before, to the current algorithm to increase the accuracy of the GUI software, or to avoid the misinterpretation of the GUI software of dual triangle and dual pentagon. So I think that's all from me. Thank you.